Welcome to Mobycast. We're glad to have you here, especially if this is your first time listening. So if you think of the trailer as the front door to Mobycast, maybe this episode would be like the entry room or foyer. It's because if you just randomly pick an episode out of our backlog, it could seem a little technical and you might be like, why am I listening to these two? What do they know about software and what did they bring me that I couldn't get other places? And you might also be thinking, how can I really learn software from a podcast? There's videos, there's books, there's blog articles, there's courses. There's so many ways to learn software. And podcasts typically are more just like, I want to listen to an interview with this famous person or, just be entertained for a while. But Chris and I really believe that we can communicate technical concepts that are difficult in this medium and that it's a great way to level up your career. But don't just, believe me when I say that. Get to know us a little bit. So that's what this episode and actually the series of episodes is about. So this was originally episode 39, and here we are remastering and re-releasing this. And it's the story of Chris early in his career when he runs up against the internet as an employee for Microsoft. And the thing that he builds there ends up, well, I'm not going to tell you what happens, but let's just say it ends up being the springboard for a journey, a startup journey that really, made his life what it is today. And it gets into some cool technology like document databases and AWS DynamoDB, and I think you'll like it. So definitely give it a listen. Let us know what you think. And stick around next week for part 2.
Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts John Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Well, hello, welcome, Chris and Rich.
Hey guys. Hey John. Hey Chris.
Hey, so we are number 39 now. It's hard to believe that in just a short year we've done this many episodes of Mobycast. Today, I think we have a lot to talk about, so I just hope you've had a good week so far and have been doing fun things. But instead of talking about that, we're going to jump right into it. Chris and I just got back from reInvent and had just an amazing time there, learned so much, met new people, and got really excited about the future of AWS. So rather than do the obvious thing, which would be an AWS reInvent recap episode, I noticed there were like 15 of those around different places and blogs and everything. So everyone's seen plenty AWS recaps, reInvent recaps. So we're instead gonna talk about one thing that really was fun and interesting for us at reInvent, particularly Chris. We're gonna do a little history today. So we're gonna talk about the birth of NoSQL and DynamoDB. So yeah, I think in order to get started, before I hand it over to Chris, I just want to say that this is going to be a little bit of Chris doing some personal storytelling because he has some real world experience that's related to this story. And so we're going to try to weave some of that into the stuff we talk about with AWS. I'm really looking forward to everybody being able to learn more about Chris's history. And then we're also going to, of course, talk a lot about specifically what AWS is doing now and how it got to where it is now with DynamoDB. So yeah, with that, Chris, maybe we can start by talking about the birth of NoSQL.
Yeah, and with that, I will totally cop to the fact that I will be showing my age here by talking about this in the context of a history lesson, right? To kind of indicate just how long I've been in this business.
You sound like you're about 27, so
good. Well, some days I wish I felt that. Some days I feel that way. But more often than not, that's not the case. So John said we were at reInvent. reInvent for me is always exciting to hear the keynotes. There's multiple keynotes spread over 4 days, I think. But the two ones I really look forward to are Andy Jassy's keynote, on Wednesday, and then follow Thursday. Werner Vogels gives his keynote, and so Andy's is kind of more along the business aspect. Lots of product announcements and kind of just demonstrating how AWS is crushing the world, and very interesting. And then the next day is Werner's turn to follow up, kind of more from a technical and kind of a vision, like where are we, where are we going type thing, and then diving a little bit deeper into technology as well, given that Werner's the CTO for AWS. And during this year's keynote from Werner, it was just super interesting and relevant to me, because he starts off his keynote with a slide saying, "Hey, I'm going to tell you guys about my worst day at Amazon." We're like, "Okay, let's hear it." And so he says, his worst day at Amazon, December 4th, 2004. This is in the peak of the holiday season, right, where they have lots and lots of orders coming through the system. That was the cutoff day for their. They had Super Saver shipping promotion going on at that time. So it was, if you place your order by December 4th, then you get Super Saver shipping, which I think was, I don't know if it was free, but obviously it was very inexpensive. That was the cutoff date to place your order in order to guarantee Christmas delivery, right? So
I'm just trying to get my head around the date 2004. So in 2004, I was working for a company called StorePerform, and we were building software for retail giants like Sears and Best Buy and Lowe's and Albertsons in order to help them make all their stores the same. So it's just interesting for me to think of that, because we're talking about Amazon, who came along and crushed all those companies. So 2004.
Absolutely. Yeah. And this is 14 years ago, right? So it kind of like feels like multiple generations away. I mean, this was pretty early days, although we'll get into this. It wasn't the early days. There were days before this. So they have this very busy day of traffic, and then of course the inevitable happens. Their database system goes down. So they were using Oracle DB, so a relational database system for storing all of their customer data, their orders, shopping carts, using it to basically power their e-commerce site. And that crashed due to a database bug. So they were down for 12 hours on that day. So you have all these customers, they've been promised, place your order by today and you're going to get it by Christmas. But they can't place their orders, right? They're getting these error messages. They're getting these screens saying, sorry, server not available, server too busy, whatever. So obviously a disaster for the engineers and for the operations people, and hence one of the worst days that Werner had at Amazon. So he sets it up,
Sorry to interrupt again, but when he said that, the only thing I could think was, well, you did keep your job, so. But yeah, I digress. Go ahead.
Not only did he keep his job, he got promoted.
Right.
So we don't have to cry tears for Werner. It spoiler alert, it works out okay.
Right.
So they make it through somehow, right? And they probably have to do something like, okay, we have to extend the deadline, and we're going to eat some shipping costs and whatnot. But obviously a very traumatic, expensive, and just really untenable situation, right? Because it's not like traffic is going to be slowing down the next year, right? This is a problem that it's now hit them in the face and they have to contend with. So obviously, as part of this, they have their, go away and do their postmortem and ask themselves, okay, what do we do? What do we do next so that we don't have this problem in the future? He talks about in his keynote where the key realization was that relational database management systems just aren't built. They're not designed for the internet, for the cloud. And this was a really core fundamental problem.
I just want to put a quick technical point on that. The reason is that our DBMS systems are like a single thing, a database. It may be that you are able to have kind of multiple machines pointing at some disks or something, but really it's not so much the databases aren't really very clusterable, or they can't be scaled horizontally. You just can't have 100,000 machines in your database, in your RDBMS database. And that's kind of what it's getting at. It's a single thing. If it goes down, you're down.
So look, this was a common theme around that time with just dealing with internet scale is, scale up versus scale out. And really, things like relational databases and even servers, like really the only answer was scale up.
Right.
The only way you can handle more load is you throw more hardware at it, right? You get a faster machine. So you double the CPU power on your machine, or you'd increase the size of the disk, or you add more memory. So that's scaling up, but you can only go so much, right? Like there's a limit to how big of a machine you can have, right? Versus scale out says, hey, instead of having just one of these things, let's go create clusters of these and let's have multiples of it. And so we'll scale out horizontally instead of scaling up vertically. And that ended up being like what was necessary in order to deal with the massive traffic and load that we have now.
And just to make sure, I sort of stated something pretty confidently, but just to make sure I really understand, I think the reason for that is that databases are super stateful. And every time you talk to them, you're basically saying, database, given your understanding of the state of the world, I want to know the answer to this question. And you just can't sort of split that state over a bunch of machines that aren't aware of each other's state. So essentially, yikes, you've got to just scale up. Like you can't just spread that out because all those machines wouldn't be aware of what the other one is doing. So it's that statefulness of databases that prevent them from being able to be scaled out very easily.
Yeah, this is. I think cozy up, people. Get into a recliner, get a nice quilt, sit by the fire, because this is super interesting, and there's so much here to unpack, and like these are all good points, and this literally, like, these are the kind of issues that were really occurring for the first time in the late 90s, the early 2000s, and this is what we were all talking about and struggling with, and these very kinds of issues. So you're kind of getting to the concept of we really need sharding, we need partitioning of data in order to have these clusters that can be scaled up individually. And relational database systems, they did not lend themselves well to that, especially with by having models where all the data is intertwined. So having to do joins becomes very problematic. Like, how do you split that data up? How do you partition it? It's just not built for that.
Right. I may be trying to read rows from one place and something else is trying to write to that same thing at the same time. And it's it's contentious.
Exactly. Yeah. And so, this might be a good point too, to kind of point out that as Werner was kind of going through this talk, and they were doing their post-mortem and analysis and figuring out like, okay, what went wrong and what can we do to fix it? And, what is the criteria here? So, they took a look at the data that they were storing in these relational database systems, for their customers, for their, customer information, for the orders, the shopping carts and whatnot. And here's what they realized. They realized that 70% of that data that they were accessing was in a single table, and they were only selecting a single row, right? So very, very simple. Literally key value, right? I'm going to go look up something by primary key, and I'm pulling back that value. That was 70% of the data and the traffic they had, and they were using a relational database system for that. Another 20%, single table, but multiple rows, right? So give me all the items in a shopping cart for a particular user or something like that. Doesn't involve any joins. It's hitting a single table. Again, not really relational data at all. It's pretty simplistic. There's just lots and lots of that data, and it needs to happen a lot, many operations, and it has to happen quickly. And it was really only 10% of the remaining data and traffic involved multiple tables, right? So they look at this as like, man, 90% of the data that we're throwing in here is really simplistic and a relational data. It's not relational data. So why are we using a relational database system for that? That was definitely one of those big aha moments for them. And when I'm sitting there in the audience and listening to Werner go through this process of like saying, okay, here's what happened to us, here's the kind of things that we thought about, and here's what we realized about the data, I was like, oh my goodness, like this is like deja vu, because this is exactly, almost verbatim, this is exactly what happened 6 years prior for me personally when I was at Microsoft.
Quick interruption to ask you to please go to mobycast.fm/show-notes and sign up for our show notes. Those give us a chance to send you the show notes once a week. They're detailed outlines that have all the information that we present in the show, which makes your email searchable. Really cool. And we definitely don't use that address to spam you. In fact, we can barely remember even to send out the show notes every week. So thanks for signing up.
I was at Microsoft in the late 90s, and I went to Microsoft. And one of the reasons why I actually got hired there was I was kind of fortunate in that I got to work on the very first wave of internet applications. So I was working for a research project at Motorola for the Department of Defense. We were building a suite of tools for engineers so that they could build like ASIC chips. And so we'd started off building all of this in just native code. It was all Unix-based code, Unix-based windowing system and whatnot. And it was a lot of work, right? And it was also like at the end of the day, it would only you had to run this on like a Solaris workstation. And so, while we're doing this is when the internet is starting to come on the scene. You have things like the Mozilla browser and web pages starting to appear. And then Java came out from Sun. And this had the promise of you could write code in your applications and it would run inside the browser. And it would run across platforms. It would run anywhere. So anywhere where that browser supported, where Java was supported in that browser, your application would run. And so we made the switch to say, instead of building this suite of applications for Unix-based systems, let's rewrite it as Java applets, so that it can. Now we have every kind of platform supported. So the net is that like using the alpha version of Java was super, super painful.
Right. Especially for a 7-year-old.
Exactly. But it was my after-school project. But it's kind of surprising how far we did get. And that work is, again, just super fortunate for me because that really led to the interest of Microsoft and their recruiting team to allow me to go to Microsoft and work over there because this is like 1995, 96. And remember, this is around the time when Bill Gates has his famous memo where basically they acknowledge, we missed this ship, this internet ship. And, we really do, like, it's time to steer the ship in that direction and it's all hands on deck. The internet is here to stay and we really have to double down on this. And so,
which arguably, they're kind of arriving at it like last year, the year before. They finally turned the ship all the way.
Yes. Yeah. I mean, it was definitely, they were slow to respond to this bigger company. They also, they had the Microsoft Network, which was, their dial-up online service with lots of applications, a robust online community, very similar to what AOL had as well. And, there are other ones, I think, like CompuServe and just a bunch of those, right? But that was kind of like the status quo. And then the Microsoft Network had millions of subscribers, right? And they were all paying a monthly fee and all was well. The internet comes along and it completely disrupts that model.
Right.
And that was one of the reasons why I went to Microsoft was like, they basically now had the charter of saying we have to switch from a proprietary dial-up network to now be an internet network. And all these applications that we had that were on the proprietary network, they now have to run on the internet. So that work that I did of building internet apps in Java was a direct link to now go do this work at Microsoft. We have these huge challenges ahead of us. Like, how do we even build internet applications? Because this is the first wave. Like, they haven't been done before. The internet is brand new. The tools don't exist for the most part, or they're just starting to come on the scene. So things like web servers, even this is like the first wave of web servers, and things like CGI bin. That was the way that you actually had web servers that you could write code for it. And I don't know if anyone remembers, but CGI bin was basically every time a web request comes in, fork a process,
right.
Right, and run that process, and the output of that process is what you return back to the web request. So we had our work cut out for us there at Microsoft. It was an interesting situation because right out of the gate, we had millions of users, and there's very few other companies out there that had that kind of problem at that scale right out of the gate. I don't even think it was like a handful of companies at that point. It could have been maybe AOL, maybe Netscape.
I'm trying to think what kind of data those users might have had, like beyond looking at just sort of what I might call today brochure type websites where it's just pure information. They're just static websites. Like what kind of user information how were they interacting with these applications? What were they even trying to do?
The Microsoft network, at that point, they had a pretty rich set of applications that people were using, and things ranging from things like message boards.
Okay.
There were, message boards, news groups, chat rooms. There were various interest groups, different types of entertainment and content. A lot of it was pretty interactive, right? It wasn't just sit there. It wasn't like TV where you just sit back and consume it. It was you were interacting with it. Some of it was games, just a range of various applications. Probably the common theme was just you're in a community with other people, right, and interacting with those people,
right.
So that was our charter. Is like, okay, we already have this existing suite of applications that work for the proprietary dial-up network, and it's all native code, and it has its own protocol for sending packets over these dial-up networks. Now we have to open it up to the internet and go over HTTP. How do you build these things? And it was a lot of work, but pretty early on, right? Discovered this. We had this big problem of how do you deliver these systems at scale, and particularly how do you scale the data? There were tools for us to scale the stateless components of our architecture. So we didn't really have load balance. I mean, we kind of had load balancers, but we called them virtual IP appliances. So it was kind of the same principle where you could have a cluster of stateless web servers, all fronted by a single IP. And it was sometimes it was software based, and sometimes there was a hardware appliance to do that. But so we could scale the load with that, right? We could have these web servers. And even with the application servers that were doing business logics per se, those were scalable as well because those were stateless. The one thing, the big thing we had a problem with was the data layer. Because at that point, I mean, really the only option was a relational database, and being at Microsoft, that choice was SQL Server.
Right.
So that was really the only repository we had for storing and retrieving data. And this was a constant problem for us right out of the gate, because we're now dealing with, like I said, we have millions of users, literally right out of the gate. We have all this data that we need to store for all these types of applications that we're building. Again, it's messaging and chat rooms and user profiles and preferences and history.
Some of that common to every single user data would all have to be in one database.
Mm-hmm. And what I mean at that point, there was not even the concept of active with SQL Server. It was you literally there was one database, right?
Right, yeah.
That was it, and you could have a backup database, but it was cold. If the active database did go down, then you manually had to cut over, right? And bring up the backup database.
Right.
So very much it was we were limited to this scale up architecture. And it was just a constant problem for us. And the writing was on the wall as well. We're having problems now, and the goal, we are going to have more and more users. Our apps are getting more and more complicated and sophisticated. We're storing more and more data about our users. This just doesn't work. The other, the big realization for us there was this is kind of silly that we're storing in a relational database because it's not even relational data. What we actually ended up calling it, we called it internet data. And really what we were describing was kind of like document-based data. It was like these snippets of data that didn't have strict schemas, but it was, and they were being accessed by key. So it was really like key value lookups of snippets of data, things again like user preferences or cookie information or history details or like chat messages, these kinds of things. That's what we were putting in our databases. That's what was causing it to fall over.
Right.
So, again, this is like 1997 and then going into 1998. That's when myself and a colleague, Marco DeMello, who was the technical program manager there with me, and we worked very closely together with him being the program manager and me being the developer. And we came up with this, like, let's go build our own database. Like, let's build an internet database for this stuff because it's really like, this is not relational. We really think that we can build something that is so much more scalable and can handle the performance. We want to have things like partitioning. We don't need things like joins. We really just need to optimize for this scaling out. Basically, and we were looking as like, you can have a load balancer for your web layer and for your application layer. What if you could have a load balancer for your data layer? Right? This is what we were going for. So we kind of got the go ahead, right, to go do this and to do a prototype. So I think we spent 4 or 5 months going and building a prototype, and we ended up taking one of our applications. It was I believe it was a message board type application that was running on SQL Server. We wrote this new database that was optimized for all these kinds of problems that we wanted to solve. And we replaced the SQL Server with this brand new database and showing the application working against that. So we got definitely some heads turned with that. And
I can't imagine how you proved though that it could scale. Like, you didn't have the option to fire up 100 EC2 instances and throw load at it. So how did you know that it would work?
So, one of the great things about working at a company like Microsoft is the level of resources that they have is quite unique. The building that I was in, just about the entire first floor was a duplicate of our production data center. Racks and racks and racks of servers.
Okay.
And we had dedicated teams, ops and testing teams. So for us to do load testing with just throwing tremendous amounts of traffic at it was like, we could just do that by walking down the stairs and going down to our test data center facility.
Cool.
So we had tools like that at our disposal. And then also just from an architecture standpoint, just showing like, okay, this is what we're doing to address. So that gives a lot of credence to it as well, backed up with things like load testing and performance testing and whatnot. So we were kind of off to the races at that point and ended up kind of getting funded internally to have a larger team to do that. So I think we ended up then adding 5 or 6 people to our team to go actually build this into something real. And one of the unfortunate things during the time that I was at Microsoft was the fact that we would have frequent reorgs that happened. So this is where the powers that be would, I don't know how exactly it happened, but I would imagine it's, get into a room and start shuffling around some papers and drawing stuff on org charts on the whiteboard and moving people around and whatnot. And so you kind of learned, like, whenever you did move, just don't even bother unpacking most of your stuff. Just leave it in the boxes in your office, because chances are in 6 months, you're going to be moving again to a different office in one of these reorgs. And so naturally, one of these reorgs happened during this time, some new management, folks leading that division that I was in, due to some politics and just strategies and whatnot. It was kind of decided, like, look, this is cool, what you're doing here with this new type of database, but we're the Microsoft network group. We're MSN. Like, that's not our charter. This feels like this should be over in the core database group, the folks that are doing SQL Server. So why don't you stop doing that and instead go work on something else? And so for me, that was the last straw.
Yeah, that's brutal.
I was not happy with that at all. And I just felt like I was, screaming into the void, where it was just like, how can you walk away from this? Like, this is a huge problem. And it's like, it's our problem today, but 5 years from now, it's going to be everyone's problem, right? Because the internet is here to stay. The internet's not going to shrink. It's not going to stay stagnant. It's going to grow. And like, we're just getting started, people. So like, this is a huge opportunity. Someone's going to solve this. Why can't it be us? So with that, that's when I decided to leave Microsoft and go found a company to go build this and to, deal with this issue. Like, how do you build an internet scale database? So that now we get into the next chapter of the story and going off into startup land.
That's where I'm going to stop you, I think, because we've spent, I think, enough time for this episode. So let's do a serial episode and find out where this goes, and then bring it back to how your new company that you're going to talk about next episode ends up relating back to DynamoDB.
Sounds great.
All right. Thanks, everyone, for joining.
Thank you. Thanks, guys. Bye.
Thanks for listening to that episode. You heard Chris Hickman, John Christensen, that's me, and you also heard Rich Statz, who was our original producer and the person responsible for the idea of Mobycast. We miss him, but we still work with him in other parts of our business. And also special thanks to our producer, Roy England. And we are real people that you can find and really communicate with, and we're available at mobycast.fm and also on Reddit at r/mobycast. See you next week.